In the first part of section 6.3, I showed you how to divide a polynomial by another polynomial. Now I'm going to show you synthetic division, which allows you to use a quicker technique for division of polynomials, but it only applies in certain circumstances. So synthetic division is a quick method of dividing a polynomial by a linear, so degree 1, binomial, 2 terms, by using only the coefficients. All of the variables are taken out. You can only use synthetic division if you are dividing by a binomial of degree 1, so that means 2 terms, of degree 1, so that would be linear. Okay, and the leading coefficient of the binomial is 1. So you can divide by, say, x plus 3, x minus 1. Those are both binomials, and the leading coefficient is 1 on both of those. In addition to the leading coefficient being 1, again, it has to be a binomial. So 2 things have to be checked before you can do synthetic division. All right, here are some things you can't divide by. Although these are both binomials, the leading coefficient is not 1 here or here. You also can't divide by something like x squared plus 2x minus 1. This has a degree of 2 on it. All right, just a reminder about some vocabulary words. This, whatever you're dividing by, is called the divisor. The dividend is what's being divided, and the quotient is what you get after you do your division. Okay, so in order to use synthetic division, you need to put the dividend in standard form. So this is what's being divided, so that's our dividend. And you want to put zeros in for placeholders. This is really important because we're taking out all the variables, so you can't tell what the degree is. The only way that you tell is by the position that the numbers are in. So this is not in standard form. The first thing that we want to do is write it in standard form. So we want to put 2y cubed and then minus y squared and then plus 25. Okay, now we don't have a y to the first power, so we want to put 0y in there and then plus 25. Okay, we're going to write the coefficient of each term of the dividend. So just the coefficient, we're taking out all of the variables. So we're going to write 2, negative 1, 0, and 25. Now if you leave this 0 out, then it's going to look like this is 2y cubed minus y squared plus 25y. So you have to have that 0 in for a placeholder. All right, now we're going to set the divisor equal to 0. What we're dividing by here is y minus 3. So I'm going to say, oops, I'm off the screen here. Y minus 3 equals 0. So y equals 3 when we add 3 to both sides. Okay, we set the divisor equal to 0 when we solve for x. These variables are y, so in this case we can say y, but quite often it's going to be x. And we're going to put this in a backwards L. So let me just kind of... All right, so we're going to do this, and we're going to put that 3 here. All right, the next step says to skip a line, so we're going to leave a space here. We're going to draw a horizontal line. Then we're going to draw a vertical bar going down that is attached to the horizontal line, and we're going to place it between the last and the second to the last number. So we're going to put it under here in between these last 2 numbers. All right, now the next thing that we're going to do is we're going to write the coefficient below the horizontal line. Oops, I just lost my light. Hold on. Okay, let's take this 2 down. So you don't do anything, just draw an arrow and put the 2 down here. And then we're going to multiply the first coefficient, so this is our first coefficient, we just dropped it down, by the divisor, so 2 times 3. And we're going to write the product under the next coefficient, so we're going to write it under here. So 2 times 3 is 6. And then I'm going to And I'm going to add in and add. So we're going to add these two together, and that's going to give us 5. And then it says repeat step 7 until all additions have been completed in all columns. Okay, so I'm going to do the same thing. Once it's down here, I'm going to multiply 5 times 3, which is going to give me 15. I'm going to add the 0 and the 15, so that's going to give me 15. And now, once it's down here, again I say 15 times 3, which is going to give me 45. And then I add 25 and 45, which is going to give me 70. Okay, this is the spot where my remainder is. Okay, now what I have to do, the quotient, which would be right here, is in this spot right here, and it's to the left of the vertical bar, and the remainder is right here. So now what we need to do is we need to rewrite this quotient by putting the variables back in, decreasing their degree by 1. So we started out with a cubed, we started out with y cubed, and now we're going to put the variables back in. So if we started out with cubed, when we rewrite this, this is going to be 2y squared plus 5y plus 15. Now this is our remainder, and it's positive 70, so we say plus 70 over what our divisor was, which is y minus 3. Okay, now I just want to say a word about synthetic substitution. Synthetic substitution is the remainder of synthetic division. So basically, if I do substitution, I should get 70. Let's see if that happens. I'm going to start out with this same polynomial, and I'm going to substitute 3 in here and see what I get. So I'm going to write this polynomial down here so you can see it. It is 2y cubed minus y squared, and there's a 0y, so just plus 25. Okay, so I'm putting that 3 in, and I cube it to get 27, 2 times 27. And then I substitute 3 in here, so that's going to give me a minus 9 plus 25. Okay, this would be 54, and then when I subtract 9 and add 25, I'm going to get 70. So this is synthetic this is synthetic substitution right here. If I were to take 3 and substitute it into this polynomial, I would end up with 70. All right, you have a couple of synthetic division problems to try on the back.